In the second example, we will add a third object and show you that the same process can apply. We're given a positive 6 microcoulomb object, a positive 9 microcoulomb object, and a negative 3 microcoulomb object. If all three are allowed to make contact, the question is, what will the final charge be on A, B, and C? So if I allow all three of these to touch and everything equalizes, what is the final charge on this object going to be? So we can quite simply apply the same mathematical approach, but we have three objects now. So the total charge, if I add those three up, positive 6, positive 9, and negative 3, I get negative 12. I apologize, I get positive 12. So I start with a total amount of charge of positive 12 microcoulombs, and I just simply have to divide that by three objects. So each object will end with positive 4 microcoulombs of charge. Again, just to show you kind of the more detailed process, we know that electrons are always going to go towards the most positive object. So initially, electrons will go from C to B as well as A to B. A to B might confuse you a little bit because they're both positive. However, B is the most positive option, and electrons will always choose the most positive option when given that choice. So what we'll do is we will take 1 microcoulomb from each, and we'll transfer that over. So negative 1 microcoulomb goes from A to B, and another negative 1 goes from C to B. So B decreases by 2 because it gained negative 1 from each of the others, and A and C each increase or become more positive by 1 because they gave that away. Now what we notice is at this point, A and B have the same charge. They will no longer transfer electrons anymore. What will happen is C will actually wind up transferring electrons both to B and to A because those are equally positive options. So it kind of adjusts slightly. So we will decrease C by 2 now because it's going to give 1 to each A and B, and then we will decrease A and B by 1, and that's where I end up with my positive 6, and 0. Because at this point now C is giving 1, negative 1 to B as well as negative 1 to A. I can continue this process again. It will transfer another 2, still no difference. We'll transfer another 2, and you'll see at this point that we end up with the same answer we had originally, just to show you multiple ways to arrive at the same answer. But the math approach is certainly acceptable and quite a bit quicker.